Hi, it's Friday, June 19th, 2020. My name is Noah Seeley, and welcome to my channel. So it's Friday today, and following our regular schedule, today's video will be reviewing some news articles relating to machine learning. We do this in order to stay up to date with the current climate of machine learning every week. I think it's important to do this, so as we are thinking of projects or ideas relating to machine learning, we'll be able to dip into multiple perspectives of what's being done and what can be done. So today is going to be a bit of a quicker video as I've only got one news article for you guys. It relates to the topic that we've been discussing all week, reinforcement learning. We actually looked at a news story last week explaining some of the applications of reinforcement learning in the future, and it discussed the implications of reinforcement learning to create more in-depth characters in video games. This article delves deeper into that idea and is called Gamemakers Inject AI to Develop More Lifelike Characters, written by Will Knight at Wired.com. I think that this is going to be a really interesting topic as it gives us an idea of how reinforcement learning can be used to make video game characters better. Video games are a great tool to test reinforcement learning, as domain selection is trivial, it's cheaper, and overall safer. But it's also important to make sure we're looking at the bigger picture of reinforcement learning. The concepts that we're introducing may set the foundations for robotics and developing more advanced technology in real life setting. I think asking ourselves those bigger questions of how this stuff may fit into the real world one day is where the excitement around reinforcement learning in a video game truly comes from. So before we get started, if any of the concepts in reinforcement learning still feel a little bit fuzzy to you, I've linked my two-part introduction to the topic in the description below. It quickly covers important definitions, concepts, and applications of reinforcement learning. I also review reinforcement literature on my channel, so if you are interested in the topic further, be sure to check that out. Now, without any further delay, let's check out the news. The article starts with saying that a development team at EA is experimenting with AI in order to advance their games. A team from EI and researchers at the University of British Columbia are using reinforcement learning to automatically animate humanoid characters, and are quite excited with the results. The current strategy EA uses to animate characters is called motion capture. Games such as FIFA will record movements from actors, which are then rendered and animated by developers. This is a long process that involves a lot of recording and coding. This also leads to a bottleneck observed in many games, which limit character movements only to that of what has been recorded. The article comments that if this process would be replaced by automatically animating AI, companies such as EA would save a significant amount of time and money, allowing them to allocate resources in other places to make games better for cheaper. The article goes on to discuss a paper that we reviewed this week called Playing Atari with Deep Reinforcement Learning by the DeepMind's technology team, a team who would be later acquired by Google. They say that this paper was able to use reinforcement learning to master a given Atari game simply by taking the pixels of the game as an input. This is basically the foundation of a lot of the advancements that we're discussing made in video games. The article discusses a controllable soccer player made without any motion capture or coding, all simply through AI, which was developed by the EA UBC team. To make this character, first the team trained a model that would learn patterns in the motion capture technique itself. They then trained an agent to be able to reproduce these patterns. The importance in this is that it creates additional animations that were not found in the original motion capture recordings. Say if the objective given to the agent was to shoot a basketball, the agent would have to learn its own movements associated with shooting a basketball. This leads to a wider range of animations, as the agent can capture a lot more over thousands of iterations without any worry for time, injury, fatigue, or even getting paid. The article then goes on to cover some other areas where AI is being experimented with in video game development, such as for world generation. Bots could even learn how to make simple games from scratch without the use of any original human-made code. Researchers at the University of Toronto, MIT, and NVIDIA revealed a program called GameCam, which can actually fully develop the classic Pac-Man game by simply watching games of Pac-Man thousands of times over. They hypothesized that simple games such as Candy Crush or Angry Birds may be developed in the future without anyone coding them at all. They have a vision of training a program like GameCam on various titles and genres to ultimately have it self-develop a game that takes the best things from these various other genres. The article ends with researchers quoting that these advancements will take a very long time to make, and that in terms of game development, their top priority is always to ensure that the games being developed by anyone or anything is fun. The future in terms of animation, though, is to be able to generate animated characters from scratch that can interact with realistic environments and worlds. That concludes this article. I think it gives us a really good feel for the current climate of both reinforcement learning and machine learning in a specific field of work. I think it's very important that as we go on, we continue to check out how machine learning is being applied in various areas in order to start thinking of how we can help use machine learning to make an impact in those areas in the future. So yeah, happy Friday, guys. I hope you learned something from today's news video, and tomorrow we'll be back to our normal content. We looked at a pretty interesting article today, so as always, I've linked all resources that I've used in the description below for you guys to go check out yourself. If you feel that I've missed anything or got anything wrong, please let me know in the comment section below. That's it for today. Thanks for watching. See you tomorrow.